Okay, this is a short problem solution video. It's a problem that was posted on a Facebook help group by a student. It's related to what we call the difference quotient, although they're really only asking for the first part of that, the numerator. So we're going to do this. There's a ton of videos already on YouTube about difference quotient in general, but this is not a difficult one to add to it. The problem, as stated, is pretty simple. And then I'll explain why this is important, what the difference quotient is, and why you will see this again if you continue in math. So let's look at the problem here. And the problem, as stated, is that you have this function g of x that's defined 7x squared minus 9x plus 8. And we want to simplify g of x plus h minus g of x. So we have to put x plus h into this function, and here we're going to need x plus h squared. So x plus h squared is x squared plus 2xh plus h squared. We have to put that in where you have an x squared in the function, and then we have to put an x plus h here where we have an x. So we have g of x plus h is going to be 7 times this, so 7x squared plus 14xh plus 7h squared minus 9 times x, so that's minus 9 times x plus h, which is minus 9x minus 9h. And I'm still going to have my 8. So this is 7 times x squared, x plus h squared. This is minus 9 times x plus h, and this is my constant 8. And I know that my g of x, I'm just going to rewrite this as given. So this is 7x squared minus 9x plus 8. And they're telling me to subtract g of x from g of x plus h. So I'm just going to take this expression and subtract it from this expression. So 7x squared minus 7x squared, that goes away. I have a 14xh and a 7h squared. This is going to go away. I have a minus 9h, and my 8 goes away. And I can factor an h out of this, so this is h times 14x minus 9 plus 7h. So this is the answer to the problem as stated. What you're doing here on a graph is finding a change in y. This is the y value, or you're calling it g of x, but on an xy graph, this is the y value at x. This is the y value a bit further along at x plus some distance. And you subtract this difference in y, and this is the change in the up and down direction. H is the amount of change you made in the x direction. You went from x to x plus h. So if I divide this by h, what I really have is change in y over change in x, which you may recognize as a slope from your straight line equations. So we're really finding the average slope between these 2 points. And I can cancel the h. Technically, I cannot let it equal to 0, but what I have then is 14x minus 9 plus 7h. And if I let h get closer and closer to 0, that's going to become insignificant, essentially go away. Then you get into the topic of limits, which is beyond this short solution. But what you're left with is the derivative. This is the derivative of g of x. So what they're doing in this problem is introducing these first steps to taking a difference quotient. We call this a difference quotient. It's the difference between these things, and when you divide it by h, you have a quotient. And then you're going to take the limit as h goes to 0, and you're going to get a derivative. So you'll see this again if you continue in math. When you get into pre-calculus and calculus, this will be one of the first topics before they introduce just the basic, simpler to use rules for derivatives. They'll go through how to do it this way. And I'll show you in a second on the graph what this is. So it's a good time right now to just understand how to do this and to make sure that you have the fluency in the algebra, because when you get into calculus you may have functions that are more difficult than this. You may have rational functions or trig functions, and you're going to carry it out the same way, and the significance and the concept is the same, but the algebra is going to be more tedious. So that's what this problem is all about. That's what they're leading to later. Let's look for one last moment here on Desmos, and that is, let me see. Okay, so here is the graph of these two functions. This is the function, the red is the function it gave you. It has an x squared, so it's a parabola. What you found, if you leave out the h in the end, is 14x minus 9. So this blue line is giving you the slope at any point of the red line. So at this point right here, it's flat. For a very, very tiny point here anyway, it's flat. The slope is 0. No change in y over small change in x. And your result is 0. As you go up this curve, the slope, it gets steeper and steeper. And as that slope becomes steeper, your result, your derivative or difference quotient becomes steeper. And I just added this green dash line to show the clearest point, which is where you have a flat point. It changes here from sloping upward to sloping downward over here, which is a negative number. So it's negative there, positive there. So that is just a little introduction to what they're doing beyond the simple part of solving the problem. There's a reason that they introduced this, and they will be dividing it by h and taking limits later. So that's how it works, and that's the solution to this particular problem, and that's it. Bye.